class explaining a tangent line, I accidentally put an equation of a tangent line here, which is not correct. I'll be showing how to do equations after. But right now, this is actually the equation for the slope of a tangent line, which now I can show you exactly how to do that. So I have this equation here, y equals x squared minus 7x plus 3, and we're going to be inserting it into this equation in order to find the answer. So when you look at the equation, you see f of x minus h. That means that for every single x, you need to replace it with the statement x minus h. So I took the original, and I replaced x with x minus h, so that's how we got the first segment. And I did the same thing for that x, and we subtracted the entire equation initially here as per the equation here. So we have the first one minus the second, and the whole thing is divided by h every single time. After we got that, we can expand it out so that we can start canceling things and bring it back in together. So I got this entire big answer here, which I guess you guys will look forward to doing later. But then once I started canceling things out and minus and plus everything that needs to be canceled, I got this smaller one here, 2xh plus h squared minus 7h. After that, I could factor out an h and put it on the outside here. So now on the inside, we have the 2x plus h minus 7. We took the h's out and put it on the outside, and it easily just cancels out with the bottom one here. Once we have our simpler limit here, which is 2x plus 0 minus 7, that's when I explained to you why I put a 0 in here, because the limit is when h approaches 0. And we're not exactly at 0, but we're so close that we're able to just put a 0 in there, and we'll be able to get a slope that's pretty much exactly what it is at that point, but it's not precisely because we're approaching, but we're not being exactly at 0. So I put the 0 in here, and since 0 does absolutely nothing, we just get 2x minus 7. And that's the limit as h approaches 0. And we can stop there, and that's the slope of our tangent line. But if we want to get more specific, we can look in the question here where I said that this is when f is at the point 5 something. We don't know what the y is, but it's at the point of 5. So if we put 5 in as x, we're going to get the slope at exactly the point where 5 is. And once again, it's approaching that point, but it's not exactly at it because a limit means that it can't exist at that exact point.
I still don't understand what a limit is.
All right, Taylor, I guess I'll explain more now. So in limits, we're going to be taking a graph here. I chose something really simple so that you guys don't get confused. And you are trying to find what the value of y is, so f of x, while you're approaching a certain point. So we have x approaching 2 here on this parabola, x squared. And in order to find the limit, or the y value, you have the limit as x approaches 2, and you put 2 into your equation, 2 squared. And that's how you know that the limit as x approaches 2 of f of x is equal to 4. That means that when you're approaching this point on this graph, that this line right here, the y value that corresponds to this x value of 2, is 4 when you're approaching from both directions. Basic understanding of what a limit is, we're going to be doing something that's a little bit more in depth, which is left and right hand limits. A left and right hand limit is basically when you have your function or your graph, and you have one side of the graph on your right side coming into a point and the left coming in from the other side, and they're meant to be at the exact same point in order to create the limit. We're going to be using the example x squared plus 4, which is shown here on this graph. It's just a simple parabola with the y-intercept at 4, and it's coming in from both the right and the left-hand sides, as we can see here. So we can plug it into the formula of limits. So we have the limit as of x squared plus 4, as x goes to 0 from the positive direction. We have this positive here, not because it's a positive exponent or because the number is positive, but because right is considered positive in this case, and it's coming from the right. When we plug in 0 here, we can find 4 pretty simply, so we know that the limit coming from the positive direction of 0 is 4, and that's how we get the right hand. We do the same thing on the left, except we have the negative exponent. Once again, not because it's actually a negative number in the top, but because we're coming from the left, and the left is the negative side. We do the exact same thing where we put in 0, and it turns out that we also get 4 here, and that's how we know that the right-hand limit and the left-hand limit are equal, which means that the limit exists. Now to show you when left and right don't exist, we need to understand what a piecewise function is and other cases where the limit cannot exist. So earlier when we found the slope of a tangent line, I explained that we were going to be doing the equation of a tangent line later, and that's what this is here. So with the same equation that we used earlier and the same slope that we found, which was 3, you can plug it into this formula, y minus y1 equals mx minus x1. And in order to get into this formula, you need to have the point. Luckily, the question had when the function was at 5. So all you have to do is take the 5 and plug it into the equation like we did earlier, and you get that at the x5, the function is at 63. So you just plug this right into the formula, and if you only had this answer, which is y minus 63 equals 3x minus 5, that's perfectly right. I would always mark that correct. But if you like it in a simpler form, you can put it into y equals mx plus b, which is something we're more used to, by just rearranging and multiplying it. So you multiply in the 3, and then you move the 63 over, and you get y equals 3x plus 48. Guys, we're about to mess you up. Do you remember your special triangles? Do you remember that?
No. Oh, wait. 737, 302, and 57.
I don't think so.
I think that's 12 valid.
Absolutely not. Oh. Alright, since you guys clearly don't remember, I guess I'll just tell you. This one's 1, 1, and this one's the square root of 2. And then here we have 1, the square root of 3, and 2. And you can actually simplify these later in order to get 1 on the hypotenuse. That just makes it easier for the big circle.
I was definitely close.
Doing equations of a tangent line with rationals and other polynomial functions, but we haven't talked about doing it with trig functions yet. So here are the equation, y equals 2 sine x plus 5 at x equals 0. First, I just wanted to find what the coordinate is for x equals 0, and I just plugged 0 right into our original equation, and I got y equals 5, which means that our coordinate is 0, 5. Now, in order to find the equation, I need to find the slope of the tangent line first. So I did the derivative of 2 sine x plus 5, which ends up just being 2 cos x. We talked about earlier how the derivative of sine is x, and the derivative of cos is negative sine. That's something that you don't really need to know how to write these initial ones. So once I've done that, I can plug in 0 as x and get 2 cos 2, which ends up as our slope just being 2. Now we can plug it into our formula for the equation of a tangent line, which is this long thing, y minus y1 equals mx minus x1. And if you were to just plug it in normally, so we have y minus 5 equals 2x, just like that, that's totally acceptable and that's the right answer. I just figured since, just to isolate the y, it would look a little bit simpler to have it in y equals mx plus b. So our final equation is y equals 2x plus 5. Understanding of what a limit is, we're going to be doing something that's a little bit more in depth, which is left and right hand limits. A left and right hand limit is basically when you have your function or your graph and you have one side of the graph on your right side coming into a point and the left coming in from the other side, and they're meant to be at the exact same point in order to create the limit. We're going to be using the example x squared plus 4, which is shown here on this graph. It's just a simple parabola with the y-intercept at 4, and it's coming in from both the right and the left hand sides, as we can see here. So we can plug it into the formula of limits. So we have the limit as of x squared plus 4 as x goes to 0 from the positive direction. We have this positive here, not because it's a positive exponent or because the number is positive, but because right is considered positive in this case, and it's coming from the right. When we plug in 0 here, we can find 4 pretty simply, so we know that the limit coming from the positive direction of 0 is 4, and that's how we get the right hand. We do the same thing on the left, except we have the negative exponent. Once again, not because it's actually a negative number in the top, but because we're coming from the left, and the left is the negative side. We do the exact same thing where we put in 0, and it turns out that we also get 4 here, and that's how we know that the right-hand limit and the left-hand limit are equal, which means that the limit exists. Now to show you when left and right don't exist, we need to understand what a piecewise function is and other cases where the limit cannot exist. In all these cases, we talked about limits when we can just easily substitute in numbers and find what the limit is and what it is at f of x. In this case, we're going to be talking about computing limits in situations where just plugging in the number won't work. The very first example is somewhere where it does work. We have the limit of x squared plus 2x minus 1 as it approaches 3. You can simply substitute in 3 and you just end up getting 14. The next example here is why we've been practicing factoring so much at the beginning of the year and with tangent lines and all that. when we have the limit of this equation here as x approaches 2, if you put in 2, you're going to get a 0 on the bottom, and that'll give you an error. We can't have that happening, so instead we factorize the top. We get x minus 2 and x plus 3, and the bottom and the top can cancel here. We just end up with x plus 3. Once you plug in the 2, you get 5. That's another simple one that works, but you need to think more about what you're doing in order to find that limit. This one here looks a little bit daunting at first just because of all the factoring you needed to do. But at first, I took out the x's out of the top and the bottom just to make the top and the bottom more simple. There's a difference of squares here once we cancel these x's, and you can just find what adds together and multiplies together in order to find the x's of the bottom. Here we see that x minus 2 is on the top and the bottom, and you can cross them both out, and we end up with the equation, the limit of x plus 2 over x minus 2 as x approaches 0. Usually you'd be able to just plug in a 0 and figure out what that value is, but in order to show you concepts that are more complex, I'm going to show you how to do this in the table of values so that you can find that the limit of h of x is actually -1.